Eu estava mute. Bom, pessoal, sejam... Yeah, I was muted. Bom, pessoal, sejam muito bem-vindos a essa live aqui no canal da Emerging Code. Essa live será uma live em inglês, onde o Ayende vai apresentar algumas ferramentas de Database Profiler, tá? E aqui vão ter algumas ferramentas abordando databases ORMs como Entityframework, NHibernate, CosmosDB, por exemplo. E o propósito aqui vai ser mostrar a vocês como é que a gente faz uso dessas ferramentas de profiling para prevenir alguns abusos, né, do banco de dados. Se vocês ainda não se inscreveram no nosso canal, se inscreva aqui no nosso canal, ative os sininhos para vocês receberem as notificações dos nossos próximos vídeos. E vamos aqui apresentar o Ayende. So, Ayende, it's a pleasure to have one more time you here in our channel. Thank you so much for being here and dedicating your time to share these tools for us. Ayende, could you please introduce yourself?
Yes, so my name is Oren, or Ayende, and I've been working with databases for the past 15 to 20 years. And I started by just trying to understand how those systems are working. How can I make the best use of the database? I remember being very excited to learn about datasets. And to those of you who are not aware of that, that means about 2002, 2003. And then I learned about object relational mappers and was very involved with NHibernate. And at some point, I got to be the person who went from system to system and tried to fix performance problem with NHibernate, which meant that I learned a lot. And NHibernate, if you're not familiar with, is an object relational mapper. It was one of the first major ones in the .NET land. It is based on the Hibernate project from Java. And being the NHibernate fixer-upper meant that I basically had to understand how database work. And eventually I got tired from fixing databases, from fixing the kind of things that people did to those poor databases, that I wrote a profiler for that, in the hope of that would make people stop hurting those poor innocent databases. And eventually I got tired of seeing that, so I created my own database so people could abuse that. And that was my previous talk where I discussed about RavenDB. Right now I want to talk about profiling databases, or as I like to call it, stopping database abuse. Now, in many cases, when people talk about why they want to profile, why they want to understand what's going on in the system, they do that because the system is slow, because there is some pain point that caused that to happen. Now, you can see this image. This is how most people envision. This is how I profile. This is how I find the hotspots in my system. And in many cases, this isn't like that at all. It's drudgery of, are we doing this? Are we seriously doing that? And other kind of things like that. I'm going to introduce the topic and I'm going to show some live demo. I would dearly love it if you ask me questions. You can ping on the chat if I understand correctly. And I will try to answer them as soon as possible. Anyway, let's go and talk about this. So this is a pool database, and this is what you effectively were kicking it. And we're kicking it quite brutally in many cases. Now, most of us have no real animosity, no real desire to hurt this poor innocent database. Stuff just happened because we're working at a higher level of abstraction. So I wrote a bunch of tools to help you figure out how you can avoid that. And that's what I'm going to talk about in this presentation. I want to start by giving you some background. And what you see here is a state-of-the-art application. This is an amazingly sophisticated system for 1980s, 1990s. And the reason this matters is that in many respects, the model that you use to store the data for this application and a modern application is one and the same. But the level of complexity that you have to deal with in your application in something like this and a modern application is many orders of magnitudes greater. And this is where we start to see failures, because you need to do so much more. So let's talk about the common issue. The system is slow. Now, for fun, there are a bunch of common issues that end up saying the system is slow. And I like those terms. VIP is RIP, so the very important customer is going to have the worst experience. And the bigger you are, the more important you are as a client, the worse we're going to make things for you. Now, why is that? What's going on? And the answer is very simple. The bigger you are, the more data you have. The more data you have, the more work we're going to have to do, and the worse the user experience is going to be. And that leads, as you can imagine, to many, many problems. The biggest clients, the most profitable ones get the worst experience, are incentivized to move away. In computer science, there is the complexity of algorithms. And if you think about that, ON square, O factorial, those sort of things are actually usually rare. You're not likely to hit them in most common cases. And given that databases already work on heavily optimized data structures, you would expect that most of the time you're going to end up with course that at around ON, O log of n, those sort of things. So a database, a customer that has 10 times more data than a small client may see minor additional costs, but not significant one. And a lot of that is because of incidental cost, stuff that we're not actually seeing. So the first thing that you always want to do when you try to understand the performance of the system is to profile. You want to have something that tells you where the time went, because in so many cases, you're going to be surprised. This is not where I expect something to happen. What you can see here, this is actually part of RavenDB. I'm just using that as an example. This is us running the same set of functions. You can see that this is called 6.5 million times, and it started at 517 seconds. It ended up 130 seconds. That's an amazing improvement that actually have impact on the user. We actually improved that since. This is from 2018, if I remember this particular one. Now, when we talk about performance, there is this tendency to assume that we have to write things like this. I will give you a second to read this code. And if you can do that, then hat off to you. That's not nice code. By the way, if you're not familiar, this is actually running in C# using unsafe code. And this is code that has been optimized to within an inch of its life. You might notice that the order of case statements is not ascending or descending. This is because we've optimized it in such a way that the more frequently accessed items are forced. So we're doing, and here you can see that we have counters. And this is actually counters in ASCII. So instead of having to compare 8 characters with 8 different machine instructions, I can do that in a single machine instruction. So this is one way of getting the desired speed. But in many, many cases, if you write code like that, you should be, I don't know, you should have your keyboard taken away because that's not something that you want to do. I don't want to have code like that, and I wrote it. And the reason that you need code like that is when you exhausted all other options. In most applications, you have to deal with this. This is, I have it hanging on the wall in the office. It's that important. And the fallacies of distributed computing are assumptions that we make, which are false, fake news stuff. And we make those assumptions because they may be true in some cases, but they're going to kill us otherwise. For example, the network is reliable. We know that the network is not reliable because if we unplug the network, well, no network here. But there's so many other edge cases that you can run into. High packet loss. Oh, I'm running over Wi-Fi and I have a concrete wall between me and the router. So this is relatively easy, but those ones are the killer in the context of this presentation. In most systems, when you're running, you have the application, that may be the web application, that may be the backend worker, whatever, and then you have the database, which is running as a separate process or machine, which means that every interaction with the database is a remote interaction, which means that you have to take latency and bandwidth into consideration. What does it mean? It means that every time that I have to go over the network, I have to pay a non-trivial cost. The example that I love to give is that what happens when I need to go to the grocery store and I need to pick up a dozen eggs and a carton of milk and some bread. If I'm going to go to the store and get a carton of milk and come back, and then go back to the store and get the bread and come back, and then go again and get the eggs, I'm spending the vast majority of my time in latency, going to the store and going back. It's much, much more efficient for me to go once, which sounds obvious, but then we realize that in many cases, we are asking the database questions in a very piecemeal fashion. So I decided to take an example. And there is this Piranha CMS project. I basically did this, and I got this guy. Now, this is actually really interesting. This is, you can see, there is a lot of SQL in here. What can this tell me? Well, I can actually look into the application as it is running. Now you can see that there's appeared to be a lot of database activity going on here. And this is actually the Piranha CMS sample application. It looks great. But I can also see quite a lot of queries. And just from the length of the query, that's a lot. Now, notice, by the way, I can see something interesting. This took 8 milliseconds. This doesn't sound like a lot, but I'm running a single server, I'm the single user, and this still takes significant amount of time. And the amount of text they have here is big. So that means that I might suspect that there is a problem. Now, if I'm going to go here, this is the CMS in question. There are 27 projects. I opened this thing for the first time today. So I have zero idea what's going on here. In order to understand what's going on, I can look, again, try to assume that we know that there is a performance problem of some kind in the system. How do we deal with that? So I've decided to do the following. Where is that? Here we go. So I've added this reference, the Entityframework profiler, and I added this single line of code. And just doing that, this is the Entityframework profiler. This is actually a beta version of the 6.0 release. I've been working on this for about, since 2009, so 11 or so years. And let me clear everything, and let's start from scratch. I'm actually going to do it like this, and have a split screen model. So I'm rendering a page. And now we can see that here is the SQL. At the most basic level, at least I get the SQL in a formatted fashion. And I can see that, okay, I'm querying on the Piranha media, apparently, and then the media version, and okay, it doesn't look too bad. Lots of text, but most of that is just because it put it inside of a nested, there we go. We just put it inside a nested item. Okay. Basically what it says roughly is get me the media and the media versions and sort it out by the ID. So I want it first sorted by the, and T in this case would be the ID of the root, and P0 is the ID of the media version. Okay, makes sense. Now, let's look at how this looks like when I'm running the behind-the-scene code. And now, remember, the only thing I did, I opened the management thing. And now we can see that there is quite a lot of operation going on here that access the database. For example, this is, you can see that we have 4 different contexts that are part of the manager login request. One of them had me loading 15 queries. And you can see that we start giving you all of these alerts. For example, in this case, hey, you have multiple object contexts, and I will explain what it is in a minute. You have a select n plus 1, and not much of other stuff like that. Here we go. Right across, okay, this is interesting. So we have a transaction violation here. Now, I have zero idea what's going on here, but looking at the code, now I can plug this into the code and double click on this guy. And a second. Here we go. So, okay, that makes sense. So now I went from the query to the actual line of code to generate the operation. And okay, it looks like I access this thing for the first time, and I'm running without empty database, so I had to create this. Let's clear things out and hit F5. I'm using the password here, so Chrome complains about this. Now we can see all sorts of interesting. Now we have probably less alerts, but this is interesting. So here is too many joins, and let's see. This is a query that goes over 425 lines. 1, 2, 3, 4, 5 joins. That's too many joins. Yeah. So this is an indication for us, hey, you need to do something. But even before we get there, let's talk about the typical issue that we have to deal with. And those typical issues, we start from the silent killer of a database. Select n+1. Select n+1 happens in many cases. For example, let's go and click here. And now you can see this. I'm accessing this particular thing, and I'm saying, okay, give me the aliases. And now for each one of those, look here, the site ID. Might be easier to just look at the parameters. I'm running the same query, but with just different slug. Now, 4 times, 5 times, 6 times, I'm hitting the server with the exact same query. This is being generated from here. Fortunately, okay. That's interesting. So this is get me, so let's go up. And again, I'm looking at what, not knowing anything about this code. I can go up and figure out that somewhere around here, I have something that called this in a loop. Here we go. Okay, so here is a loop. And here is calling the database in a loop. So this isn't actually the classic select n plus query. We will actually see a more classic example later, but now you can see something really interesting. I literally just started this application. And I can tell you that this is a problem. It would be far, far more efficient to go to the database and give it an array of slugs. And go down in here. And there's a whole bunch of code here. Instead of giving you a single one, you want to do something like that. And the reason this would be better is that you're going to reduce the number of times you're going to hit the database. And that's important because going to the database is where it's at. Going to the database is where most of the code goes. This is because it's not about complex queries. This is an issue, and you will see that. And you may, we already saw that there are a lot of joins here that we have to deal with. But in most cases, each one of them is a tiny pinprick. But you have a zergrash of operation on the system. Remember, right now, I'm a single user accessing the database very, very slowly. Try to imagine that I'm 100 users accessing the system concurrently. And suddenly, accessing this particular page means that you have 1,600 queries per second to deal with. And that's ridiculous. Now, another thing to notice here, which is very important, is that this CMS is actually quite amazing. I don't want to detract from its capabilities, but by default, it is using SQLite. SQLite is an embedded system. Why does it matter that this is an embedded system? It matters because an embedded systems mean that you don't have this cost of going over the wire. It means that the cost of issuing one query or multiple queries is roughly the same. What I've done right now, I changed this. So this would actually run against, again, still a local instance, but at least a remote one. And now we can start seeing how is it going to respond? What are the actual costs that we have here? Another thing that is really crucial to understand, look at what we have here. I was able, within the span of, I don't know, 5-7 minutes while I'm speaking to you, to identify a problem, calling the database in the loop. And without really understanding how the system is going, just because what I'm doing here, this is the whole point of the system, is to plug into the middle between your database and the application. We're basically enhancing the capabilities of, in this case, Entityframework. We also have the same thing for NHibernate or CosmosDB. But the idea here is that we track all of those operations. And we're able to understand the context of the operation from the point of view of your application.
So I think that could you increase the font size? I think that is make better to attend and see the text on the screen.
Absolutely.
Okay,
so
thank you.
Here it's easy. And I will go like this when I need to show something. But basically, yeah, you can see the stack traces here. You can see the sort of alerts that we have. And there's quite a lot of alerts in here that we have to deal with. Now, I mentioned that we have a selector plus one across multiple object contexts. This is a problem. And again, I don't want to go into too many details about specific issues, but this is a good example of the kind of issues that you might run into for real. So if I'm going to go here, you can see that I have a get query. This uses this DB. So going more deeply into SQLite, so let's see if we have anything here interesting. So this is the model of the data. Now, what is interesting is that the profiler complains that we have multiple object contexts, which means that we have multiple of those being created. I can go up the stack and try to see why this is the case. And here's the API and pages. And presumably at some point in here, I'm actually generating a new instance of this. I don't know what exactly is going on. From my perspective, it looks like to be okay, but probably the profiler is objecting to multiple instances of that. We need to look in more depth and probably have better understanding of the system. But we can see where those kind of issues happen and how they are handling that. The reason this is a problem is that an object context in Entityframework in NHibernate is also a unit of work. So if you process that if you try to load an object that already loaded in the same object context, you can save the cost of going to the database. It also means that if you want to save things, and let's do some saves and see how that works. Let's do save. Okay. Remember that I restarted. This is now running on SQL Server. I might want to force it to start. Yeah, I think that, okay. Okay, now we have made it the, okay. Content. So, and again, I really like this title field. Okay, now let's look at what he did here. And this is probably one of the latest one. And now you can see here is the draft. And we complain about too many nesting select statement. What is that? Okay, so one of the things that we can do now, we can go and look at the query plan for this. And again, you can see there's a lot of going on. So we can now go and see exactly what's the cost of this. What is the cost of this query? Now, this is usually something that you would see from the DBA perspective. But you can see that, okay, I'm joining posts and categories, and then post permissions, and we have tags and more tags, and we also have post blocks and more blocks, block fields, and post. And basically, at this point, I would tell, if I would look into that in my application, go and use RavenDB, because you have a complex data structure that reside in many places, and you're paying for that. Here is the other side. Again, too many nested choice statements. But now you can see that we have all of those inserts. Again, we have to insert into quite a lot of locations to have a single instance. One of the reasons that we want to use a single object context per request is very simple. We want to avoid splitting my transaction into multiple independent operations that are not in the same transaction. You can see here that we call save changes in Entityframework. And this is not a query. And we have a begin transaction, commit transaction. But every different object context has its own transaction. If you use multiple object contexts, then you don't see that. You won't see the, you would have different transactions, and you may have a transaction. For that matter, you can see that processing a single request was done on multiple individual object contexts, because each one of those is an object context. And you can see that here is this query index, this query query. And it looks like something very similar to that is done again. So there's quite a lot of things that we can do, and we can look at the data and see how it matters, how things are running. I can also do analysis on the whole thing globally. So show me all of the unique queries, show me the expensive query. Here is, apparently this is quite expensive, which would be, okay, so we are creating a new table. That's expected to be expensive. But this is actually expensive. That is a big surprise. This looks like it would be a cheap query. So this is the query in question. When looking at the query plan, there isn't. There is no reason for this to be no reason for this to be a SOAP query. But we saw that. Maybe we pay on the network costs. All of those things are things that we have to consider. But now we have the ability to look at that. We can also start looking at, okay, where am I spending my time? What queries are happening for my code? And this is something that I couldn't emphasize enough. Any database that you will use, except maybe SQLite, is going to have its own internal tools, stuff that you can use in order to understand what's going on. SQL Server has SQL Server Profiler, Tooling Advisor, a whole bunch of other things that you can use. But what they do, they give you the context of a single query. Even the Tooling Advisor, it's going to look at a set of queries and then give you what are the queries that you need to do. What are the changes that you need to make to your application, to your database, to optimize the query? What we're doing here is we're going the other way around. We're saying, okay, let's look at it for my application. Let's give you enough context to understand what's going on. For example, just looking at this, I have these queries. Why do I have these queries? And looking at that, okay, this looks like permission. This comes from the middleware. We saw that. And somewhere around here, there is permission to see if I have access to this. Here we go. So this is here, and we are not in the assets. So we have to run a permission check on those slugs. Now, do I need it for this? Probably not. And again, those are three separate queries. You can see, by the way, this is interesting. This took 0.031 seconds. Not a lot of time, but this is just time that we can eliminate completely. There's a lot of checks here. CSS. Why are we paying for that? Now, on the other hand, if you're looking at here, you're going to say, oh, let me see this query. Oh, by the way, this is, this is, I want to, oh dear God, this is, by the way, notice, this is the kind of query that you want. This is not a simple query. Just looking at the query plan. So looking at this, there isn't anything here that jumps to me. There's a lot of cluster index scans. Okay, maybe it could be an index seek instead of a scan, but there isn't enough data in the database for me to actually know about that, to actually optimize this. And again, I'm now in the role of the DBA, trying to optimize this. In my hat as a developer, oh wait, this is a JS file, this is a static asset. I probably forgot to enter the tiny in here. So let's see how many queries I can eliminate just from this, and I'm probably forgetting more. Just something utterly ridiculous. Now, so again, the whole point is this. Each one of them is tiny, but they add up. And at the end of the day, you're going to see quite a lot of issues here, quite a lot of basically at this point, okay, how do I even start handling this? And okay. So as I said, this is literally all of the changes that I had to make to the application. And then we get started and we can start running. And the whole idea is that I don't want you to be an expert in the database. See this, understand what your application is doing. And I chose the Piranha CMS project intentionally. I'm not familiar with it. So it means that when I'm looking at that, I'm at the same position as most of the people who look at the database or at a slow database system are. This is not a trivial system. Typically, when I'm talking about optimization profiling, I'm narrowing things down to a function. And then I do evil things to that, like this, until it's fast enough. The common problem that I have to deal with optimizing databases is that in many cases, yeah, I have the slow queries. I can introduce an index, I can ask the DBA, whatever. But in most cases, I'm going to have to deal with the dead by 1,000 cut. Okay, so I mentioned already that this, I'm doing the demo on just the Entityframework. The exact same thing also apply for NHibernate and give you the same level of insight. Now, there are other environments that we have to consider. What happened on the cloud? So on the cloud, the situation is actually typically much worse. Why is that? This is what happened when I'm running locally. I'm using SQLite, I'm using a local instance of the database. In the cloud, in the cloud, by definition, I'm using a remote instance. So no more the ability to do shared memory pipeline. Now I have to go over TCP, go over typically different area in the data center. That means that the latency, the bandwidth costs that I have to do are that much greater. Now, I wanted to give you an example. And I'm just going to make sure that everything fits in a single screen, and then I will increase the font size. So what you can see here is a pretty simple, as much at least as I could make it, a Azure function. This is actually an interesting problem because what's going to be the cost of running this? And how I'm going to be able to profile something like that? Well, I'm running on my local instance. What actually happened behind the scene is that this is acting as a server and the application is just sending the data. But now this is running somewhere, and by definition, this is serverless. I have no idea how it works. And I'm going to give you just one moment. Look at this code for a second and try to imagine. And please use the comments. Put it there. I want you to give me a guess. What are the issues that we have for this code? Where is it going to hurt us? This is basically what I'm going to ask. So let me run this while you're thinking about this. So for the purpose of discussion, I'm actually running this locally. I've learned my lesson about trying to work with cloud stuff for live demos. So this is running, and I can go here. and run this. And here's some results. It's seems fast enough. And let's see how that works. Nothing shows up here. I'm going to do this. I'm going to connect to an Azure channel. And suddenly, I can see results that happen, but results that happened in the past. Let's run this again. And in a second or two, I'm going to have another one like this. So let's see what we have here. Here's one invocation of my Azure function. And I already see that I have a problem. I have a select m plus 1 in here. That's interesting. What's going on? This is not a lot of code. This is actually a key aspect of what I'm talking about here.
It's a Navy code, right?
It's a lazy code, exactly. But you're not seeing that. This is invisible to you. And this because the whole point of the way the system works is that your functions of small composable pieces, you're not seeing those sort of things. But this is actually a time bomb. There are actually multiple time bombs in here, which is funny. Look at this code, and there's what? Let me just get rid of everything that is not interesting. We're talking 28, so less than 30 lines of code. Well formatted. I could make this far less. And there are multiple hidden bombs that are going to cause you to spend a lot more effort, a lot more time, a lot more money running this. So the first item is actually the fact that we are running a select m plus 1. And we can narrow down to the exact line of code, this thing. What happened is that we iterate over the recent posts. For each one of them, we're getting the count of comments. But notice how we do it. We do it in the slowest possible way. If we have, this case, I have a blog post, and I'm getting what looks like to be the most recent, so give me the last 5 comments of the last 5 of this blog post. What if I have a blog post that has 500 comments, 1,000 comments? This innocent looking code is going to load all of them. So that means that we're going to spend more time executing this function. We're going to use more memory, all of which we're going to be charged for. The SQL instance that we're running is going to be hammered because now it is doing a lot of work for absolutely no reason. For that matter, we have other alerts that we have. Unbounded results set. See this? Why do we have unbounded results set here? Passing take. Oh, you see here? This isn't used, and I did this work on the output. So what this actually does is saying, okay, let me load this up. All of the posts that I have on this blog post, or all of these posts that I have for this blog, my blog has 7,000. So if I'm running this on my blog, this says load 7,000 items, get the first 5, and discard all the rest. And then do more work here. Absolutely crazy. And absolutely hidden. By the way, the appropriate way to run this, to give you some idea, would be something like this. Just going to do this so we'll have something to compare. Okay. Now let me run the same thing again. Starting. Hopefully I did everything. Same input, same output, sorry. But now, okay. So give me the post and the blog. So that's interesting. And now this. By the way, why do we have this? This is strange. This is because I still have this. So I probably need to do it like this. Okay, now run it again. Here, notice what happens. I don't have to guess what's going on. I can see. And that matters because eventually I'm going to say that, okay, here is the single query that I have. And this match everything that I want to do. So it is properly paged, so you don't have to worry about unbundled result sets. It's not doing a lazy loading. If I have 10,000 comments on a post, this is going to get that efficiently. And everything is easy. One query instead of the 7 that I had here. And the 7 that I have here is actually lucky because I may be here getting tremendous amount of flows. So this is actually interesting because of the implications of using the Azure channel. So in order to make this work, I have to, again, in this case, I can't add one line of code. I have to add multiple lines of code. So this is what I have to do. I have to tell it, log it to Azure. And interesting about this is that this breaks the immediacy between your system and the profiling action. Because now we can say, okay, let's do that after the fact. So we set this up, and now we're seeing that the costs are higher. So I can just collect and says, okay, give me the result, show me what's going on. And then I can see that. I can analyze, operate. You can also do all of these programmatically. One of the things that we've really tried to do was to allow you to plug this into your CI infrastructure. So you can actually run your code and say, are we violating any of the recommended rules? Are we seeing too many queries for this particular place? Do we see selected plus one, those sorts of things? And again, when we're talking about projects like this, which has a lot of projects, lots of moving pieces, that can help tremendously. Especially because, by default, we use SQLite. Everything is happening in the same process. It's fast. But then you go to production, then you have lots of data, and now you start paying for that. Now, there's also CosmosDB. In addition to the Entityframework and the NHibernate profiler, we also have a dedicated profiler for CosmosDB. And this is because CosmosDB is not just a standard database. It's globally distributed, multimodal, and it's meant for if you have a lot of data. But the key aspects of CosmosDB is that you have to really think about how you structure your data. This is because of those features. You have reserve capacity. This is what you pay, and you pay for the size of the data. There is not much you can do about the size of the data, but the issue of the reserve capacity is very important. How you query and how you operate is tremendously important. And the CosmosDB profiler can give you a lot of insight into that. This is because when you start getting charged for that, immediately, then you realize that, okay, I have this inefficient query, I'm burning cache. So here's a few examples. You can see this query. It doesn't look like anything bad. But notice what we have here. We can analyze. So again, this is very similar to how we looked at the request from Entityframework. But now we have a dollar value that is attached to that. If you have 100 users running concurrently on this thing, this will cost you 20 cents. So now you can actually apply cost-based optimizations. Hey, what is my literally most expensive? Where I'm going to spend the time paying?
Yeah, this value, but this value is extremely important to developers and to the company, Ayende, because sometimes developers decided to use CosmosDB as a globally distributed database, but they can't imagine or calculate how this decision will make cost to the company. And using this kind of tool, they will be more vision how they can support the cost in the near future, right?
Yeah, just to give you, and you're absolutely right. A good example is that, okay, we started building the system and we thought that we would model everything and we partition everything by the user ID, which is a very common thing to do. Then we realized that we actually shifted a little bit. A lot of the operation need to run based on what city you're on, local community, those sort of things. And suddenly your queries can't use the partition key, so they have to hit all of the partitions, and they're incredibly expensive. Now, this is at least something that you think about. This is obvious. But look at this query. I wrote this query because I got a bug report that, I want to be able to search on city and don't worry about the capitalization. Is it New York? Is it New York? Those sort of things. So I wrote it. It went to code review. I mean, okay, yeah, it's obviously correct. I added the test for that. Everyone is happy. This is going to cost you because you cannot use an index here. If you cannot use an index, you have to do a full scan of the database, which again, this costs you a lot of RUs, which is money. Now, every time that someone searches a city, the cost of this is proportional to the amount of data that you have, which is going to slowly go over time. When I'm running locally, how much data do I have? 20,000 items, whatever. I'm not seeing that. I certainly not seeing the actual cost, and you need to expose the sort of cost to the user. because otherwise you may end up with, okay, the lifetime value of this customer is $500, and if they log in once a day, we are losing that, which is ridiculous, but it gets to those levels. Okay, so, and again, you can drill down. A lot of those things are similar. You can look at, in this case, those are a lot of details that you get from Cosmos, how much it is used, all of those sort of things. But you can also look at the stack traces and where this happened and have this concept. One of the things that I used to do, I used to have a bet with people that I did code reviews on. I would say, I'm going to find you select N+1 within an hour of me running the code. I'm hitting F5, I'm running the code, I'm going to find the select N+1. By the way, we can try it right now with Piranha. It's going to take us, what, another 2 minutes to find another select N+1? And this is, again, professional code, and I went over that. It's nice, but those issues are so pervasive that they happen all the time. I actually want to do that. Let's go and find Piranha. And let's look at config. Config is interesting. Admin, password, highly secure system. Yes, I know this isn't data breach. Okay, so login. Again, multiple object contexts. Here is a select N+1 on users. Why do I have that? Okay, again, insert. I'm going to ignore that because apparently it does something. Let me refresh this. Okay. Oh, how nice. Here is the select N+1. Didn't have to do anything. And by the way, you can see here, this is going to be trivial to figure it out. So this is last inquiry, so I don't know exactly where it's coming from. Let's see. I'm going to make myself a slightly easier time. So this is load the parameters. This is, what is this? Load the fields. So no results here. So it's just, this is strange. Let's look at this. Oh. No, I don't want to check in the C#. Here we go. And from here, let's see where we have the next select N+1. Here we go. This is horrible. Why is this horrible? Because look at this. You're saying, leaving aside this thing, why is this done this way? It would be so much more efficient to load everything in the table instead of accessing one at a time. By the way, you can see every time that I'm accessing this, I have to pay for that. That's ridiculously expensive. By the way, notice another thing. Is a service. So I'm using it just for this. Here's the multiple, but this is probably where we have the multiple items. Each one of them has their own DB set. Again, I'm not even trying to find those issues. Let's go to modules. And another thing that is interesting here is that there isn't any sufficient data. Okay, this is this is getting sad. I mean, everyone that I'm seeing has those issues. So if I had sufficient amount of data in the system, I would start seeing significant slowdowns. Again, very nice code, well maintained, and I'm able to pinpoint all of those issues one at a time. Okay, this is specifically for the CosmosDB, but also apply to the Entityframework and NHibernate ones. You can, one of the nice things is that you can just throw the data into a blob storage and analyze it after the fact. This is especially useful if you need to do auditing of queries or those sort of things, because it just gets stored. It's very cheap to do that. And eventually you get to the specific line of code that calls the query. And that gives you context in order to understand what the problem is. Now is the time for questions.
Yeah, sure. The people that are on the chat, please write down your questions, and Ayende will answer your questions, please. So when we are waiting for the questions are coming, so Ayende, it was a great session. Database profilers are important tools on daily basis of developers, because sometimes we are very happy when the applications that we are developing for is just running and then delivering the business features, right? And making our stakeholders so happy too. But that feature, it's not working as well and computing as expected, because the performance is slowing down and the queries is not right in the perfect way or in the right way. And in the near future, we will face the performance issues. So these kind of tools, I really recommend for every developers have on their daily activities, because this is very helpful too.
I think that it's also important to remember that using something like this, it's not supposed to be this is not the IDE. You're not supposed to leave them, but this is supposed to be something that you do at least occasionally, once a week or so, twice a week, in order to just maintain a certain level of consistency in your application. If you're not doing that, then again, it's going to end up piling up. And one of the hardest issues that we have to deal with is how often do we start to suffer from all of those small issues that end up spiraling out of control. And again, you can actually see that in the code without actually looking anywhere. If I'm going to look at who is calling that, this is being called, and there is a cache that I saw somewhere around here. So there are quite a few caches that we have here. But if we go and look at why do we have these caches, it's like I see it here. It is trying to avoid hitting the database, because it's obvious that hitting the database is expensive. But the cost of doing that is typically okay. We do cost and we try to handle all of that, but we don't need to do all of that. We can just use the database directly, avoid having to spend all this time thinking about caching and cache validation, those sort of things. Because if we just use the database properly and efficiently, there is a joke about there are three things that are hard in computing: naming thing off by one error and caching validation. And this is the case. And in many cases, this is not done. All of those things are not hard. You don't have to do something. This is something I think is very important. This is not hard. This is just, oh, I can see that we're doing this here. Let's apply one. Let's, for example, with the config, let's just load the whole table, one query, and that's it. Or do an in on this, one query, that's it.
We have a question from David Woods. He is asking any recommendations on where to start with an old or large system. We have thousands of alerts, I am sure.
So the easiest way to start with, go to run it, and you will have a lot of alerts. Don't worry about that. Go here, start looking at the queries. Start seeing what is expensive. Start seeing the unique queries. Important, look at the number of queries that you have here. Again, dead by 1,000 cuts. This is you can also go here and see exactly where this happened, and then go and look at the stack trace. You can see a whole bunch of details about that. Now, the reason this is important, you start by looking at the most frequent issues. The expensive queries and the number of queries is the number one thing that I would recommend looking at. Maybe look at the alerts. This is something that you probably want to look at. You have red, orange, and green to give you the severity. We also try very hard to give you the in here more information, how to solve it, what's the issue here. But consider the fact you have a system that is running right now. But if you spend the sprint going over and clearing those things out, even if you only clear the easy things, right now I'm clearing 13 queries. Right here, 3 queries, or however many queries you have in here, because this is actually manager API and permissions. So the deeper it is, the more you have. So a change here in the middleware that we saw previously would cut down the number of queries that you have by a lot, which is silly.
AG is asking for sending a question for us. Would running this in production be a drain on performance, or is it optimized for something like this?
You can absolutely run it in production. There is a performance penalty because it has to do its work, but it's not a major one. There are 2 ways that you can run it in production. One of them is like this, and this is write it to Azure and set it free. You can also set it up so the storage account would expire after 30 days or something like that automatically. You can also do this, initialize for production, in which case this opens up a port, and then you can basically, until you connect to that from the provider, it's just sitting there and doing nothing. But you can connect to that. Notice that this is something that you want to run inside your network. Don't run it over, don't expose that to the public internet, obviously. If you want to do that for the secure system for that, use this. You can also do this. This is really interesting because this is meant for, okay, I'm just going to throw it into a file. And if there is a problem, I can go and read and recover and look at things. So this is very similar to this, except that this is for completely offline mode. This is also something that you can do for a CI, and then we actually provide API for you to analyze this, to see exactly what's happening in your system. So, oh, am I meeting my performance goals? Dave previously asked, how do I use that in an existing project? In an existing project, the answer is that you read a little bit at a time. But if you have a new project and you use something like that, then the whole idea is that you prevent the read from going in the first place.
I have a question about the versioning where we can use this tool for. So does it recommended to use the Entityframework profiler on the new one version of the Entityframework Core 5.0, for example?
Mm-hmm. So the Entityframework core team made a lot of improvements to the system, but you will notice something very interesting here. I'm not seeing anything here related to Entityframework itself. I'm not actually thinking about how it does that, except maybe the kind of SQL that it generates. What I'm looking at more is the interaction between the application and the database, and Entityframework in this case is mostly the medium for this interaction. When I rewrote this code, from this thing to this thing, I care that it knows how to translate this to the appropriate subselect, yes. But it almost always has been able to do that. So the performance improvement things that it was able to do are interesting, are important, but are almost irrelevant for this. Because yes, you will be able to run faster, but if you're running faster only to run these sort of things, then there is no benefit for you at all.
Okay, and you said that we can use the integration of these profilers in our CI and CD process. So, and what is the metrics that we can extract from these profilers, and how can we integrate it with our CI/CD, making us able to broke our build process or not, or this integration is can't be done.
There's a whole bunch of things that you care about. Where is the lots of API? I'm trying to figure out where is the link pad. How much of things I'm. No. This is the common thing, but what you care about is the CI stuff. And let me see if I remember where it's at. Sorry, NHprof, CI profiling. Yes. There is an API that I can't remember where it's at. Here we go. That's the API, I think. No, go away. Go back. Here we go. That's what we need. No, I want this thing. Okay. Can I get this image? Thank you. Okay, so this is the API. You effectively, you can say it, capture, blah, 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 and then you say stop and return. And notice something really interesting. This is, you get effectively a report And this report is almost identical to the user interface that you have here. So for example, here is the sessions, and here is, those would be sessions. And here is a queries, and here is a particular query which has alerts. So here is a session, particular query that has alerts. So there's a one-to-one between the object model that you have here and what you see. And you can basically alert on, okay, I want to see if I have any alerts whose severity is higher than green. I want to see if the number of queries that I made exceeded my SLA. Am I violating this or that, and almost other stuff like that.
Okay. Thank you so much for your response and your answers. And if we don't have any questions, I think so. We don't have any more. So Ayende, one more time, thank you so much, and we appreciate your session and to meet these tools, and be aware that you and your team are evolving this tool to support us and help us to be a better programmer and build better systems around the database application. So thank you so much, and I hope see you again in the next sessions, right?
Yeah. Thank you for having me. Have a great time.
Okay.
Bye-bye.
Bye.